Welcome back to the next installment of K5 Coding and Computer Science Elementary Grades webinar series. So this webinar is focused on inclusive computing cultures. This is going to be mainly a dialogue around how do we promote equity in both our classrooms and how our students interact with their artifacts, interact with their peers, and interact with the world and in the products that they design. So much of this pulls from the K-12 computer science frameworks. Just to read this was resonated with me. Equity is not just about whether classes are available, but also about how those classes are taught, how the students are recruited, and in line with this particular webinar session is how the classroom culture supports diverse learners and promotes retention. So this is a huge issue in computer science, and I believe that K5 is in the best position to begin to ameliorate some of the issues that we're seeing longer term. We know that the research does show that for female students, for example, they begin their schooling, and over time they receive these signals time and time again throughout the day over the years that tells them that they can't do science, they can't do math, and they can't do computer science. That's one example. And we also see that there's some ethnic disparities, especially in the types of courses that are offered, the quality of teachers, and that kind of thing. So just to stress that point, that elementary teachers are in the best position to begin to show all students that that computer science is definitely a field for them, that it's very useful to their everyday world, and it will open their eyes to many things that they were not aware of before. So the practice that we're focused on is fostering an inclusive computing culture. This is practice number 1 in the K-12 CS framework. There are really 3 areas that I'm going to focus on today, and that students should be able to, number 1, include the unique perspectives of others, address the needs of diverse end users, and employee self and peer advocacy. So the first one relating to reflection of students on what their interests and desires are in terms of the choices they make with how they use technologies, and then to put themselves in the shoes of other people who may use the technologies that they produce themselves. And the second one focusing on the needs of the people that are using the technologies that you will have your students create in the classroom to ensure that they reach a broad range of people and are usable and accessible by those end users. And then for students to gain a sense of advocacy, being able to advocate for themselves and their own interests and their own needs and what is accessible and usable for them, number 1, and that puts them in a position to begin to advocate for their peers and people that are not like them or like them. So the first one, including the unique perspective of others. So this one is important in the elementary grades, and this is something that elementary teachers do all the time. I know that my daughter in kindergarten, and even I've seen this all the way through 5th grade. The first day, it's an all about me project, right? So they're going through and it's basically a get to know you project where students are getting to know their peers and maybe presenting something about themselves and really hitting on their interests, their hobbies, what they like to do, what they like to read, those kinds of things. Elementary teachers are very savvy in doing this, and Even middle school and high school teachers do something similar, some type of icebreaker. But at the elementary level, it is much more focused on projects, and that's a great place to begin to introduce some of the differences that students express and how they use technology, what have they created before. In the upper elementary grades, definitely just putting the students into some type of technology where they're using some presentation software or something along those lines to express themselves and to get to know their peers. But this takes that piece and that kind of introduction to who I am to another level, and takes us into the aspect of reflecting at a critical level on what my interests are connected to what I create in the classroom, what I create at home, the code that I use, the vision that I have for a project that I'm produce, for example, a video game or something like that, and then how I design that project along the way. So computer science experts have really hit on this. A lot of research out there on the projects themselves and what that tells about a person and how it's designed and what is produced. So in my mind, this is step number one, a critical reflection of students being able to think about what are their needs, what do I use, what technologies are accessible to me. And then at that point, making that juncture to thinking about the perspective of others for the young learners, at least. So knowledge and skills around that. Number one, that as students design, let's say, for example, they're creating, I'll use video games, and let's as my own self being a male, let's focus on female students who may be interested in creating a social game, a game where they're creating an avatar that is themselves, and then there's a series of interactions of sprites and in a village of sorts, or at the mall in a food court. So understanding that as the students are creating those objects and creating how those objects interact, that they are making choices in what those interactions are going to be, and it's based on their interest. And even the young ones, they understand that. They can, when you're asking them, why did you choose this? Well, I chose this. I chose a little girl because it's similar to me, and she has blonde hair like I do, and she's interested in, if it were my daughter, worms and bugs and stuff like that. So they begin to see that the whole project that they're creating, and again, going back to the earlier sessions, artifacts, computational artifacts, and in our world as teachers are projects in the classrooms that are developed computationally, and they're able to make that connection. What can be more difficult for them, and this is based on their experiences and their exposure, is, and teachers understand this at the elementary grades level, especially, is understanding that the choices I make in creating my project might actually limit who can use the project, like say in another grade. If I'm a female student, perhaps and if I'm a female student in second grade, perhaps a fifth grade boy may look at my project very differently and not be very accessible to that boy. So beginning to take that next step in considering the perspective of others as they create their projects, okay? And that along those lines, as they begin to consider these perspectives and learn about them, then they begin to make different choices in the projects that they create. And again, going to different perspectives, different perspectives and backgrounds, different perspectives in ability, different perspectives in how other students view the world or adults view the world. And usually teachers do a great job of this. In just, and especially the social science courses, teachers often have students, as students begin to write at the younger grades or narrate stories, they do have the students consider the points of views of other people. But where this is lacking is at a very, very high level is in the technology fields, in the hard sciences, in computer science and mathematics. This perspective piece is missing. And so if this piece is missing over the course of K1, K2, kindergarten, first, second, all the way to fifth grade, then jumping into middle school and especially high school, then it's more difficult for students to begin to view those perspectives from the aspect of how they view technologies, how they view computer science, and their interest at the most important level is their interest in those fields. So it's no surprise that by the time students get to middle school, oftentimes and by the end of middle school, their interests have already been solidified in what they want to pursue later on in high school, or their interest in occupational fields and what they like to do. Those have already been solidified, and those are the product of years and years of education and their lives, right? So this is how we begin to alleviate some of those major issues that we see in computer science education today. So going back to the next step. The next step, and even as teachers, I mean, me being an educator, this is something that I think about all the time. I'm limited in how I can teach my students based on my experiences in my life and the perspective I come and bring to the classroom. So the only way that I can begin to understand different perspectives is I've got to seek that out. And at the K-5 level, that is very much at a social level, and for everyone. But social learning is so important for the younger ones that they have to be taught the skills and how they go about seeking out these different perspectives. So it's an easy one for the classroom, and teachers do a good job of this. They group students, they have students work together in pairs and in groups, and especially with project-based learning, this is something that just goes hand in hand. So there is that collaboration and that inclusive culture that occurs in the classroom. That's one thing that I'm talking about. But what most often happens, and tomorrow when you're in class, just remind yourself in your classroom, do all the students look very, very similar? Are they the same race? Are they the same ethnicity? Are they the same they're the same age level, right? So our schools are structured in a way to where this third piece here is very difficult to do in schools. So just keep that in mind as we think about these topics. So number one was including the unique perspective of others. Number two is, and this is where computer science education is well leveraged to promote this, because as students develop their artifacts or their projects, let's say, for example, they're doing a simulation of some type of phenomenon, some of the ones that I've showed you on the Scratch platform, or in the case of a game, or perhaps they're working on a design of a city or something like that. Usually how they're thinking about this is just from their own perspective. But as an elementary grades teacher, you can structure your classroom or your projects in a way to where they are very much considering the end user in mind. They keep that end user in mind, and that is during the design process, because the design is going to be reflected in what is produced. So the goal here is to broaden this access and broaden this usability as much as possible. And there is some benefit also to narrowing it. Perhaps there's a group that have been forgot about, so to speak, in a particular design. So this comes into the forefront during the design process, thinking about how accessible is, for example, a virtual reality type of technology when the person who is an end user is blind, for example. How accessible is that? Well, it's not accessible at all unless there's some audio components, obviously, and some tactile and some of those components to actually try to immerse someone who doesn't have the visual capacity of other people as end users. So that's what I'm getting at. And how usable is it? For example, in my age now, I've recently came back from the eye doctor and was letting them know that I'm squinting a little bit whenever I'm reading. Never had that issue before. Even without contacts or glasses on, I could read, no problem. And I've come to find out there's a muscle in my eye that in older age becomes more difficult to activate, so I have to wear reading glasses. So if I'm designing something that is using text, for example, in the K5 level, how big is my font? Am I considering that the end user may have difficulty seeing that size font? Because we know that K5 students, their eyesight are usually superb. So those are easy ones to discuss in the classroom. So the knowledge and skills around this, again, going back to the differences in accessibility and usability. How easily can it be accessed? And that even points to is it a product that is going to be, for example, uploaded on the Scratch website where anyone who can have access doesn't have to pay for it, and that's accessible. But then let's say that one is posting a project in Scratch, but they don't have that particular computational artifact in the format of, say, an iPad or accessible on one's phone. So that is one way to think about accessibility. But also usability, and once someone has been able to access that technology, how do they use it? As a student, and say third grade, I'm building, let's say that I've programmed my sprite, my Scratch cat, to move in a certain direction across the floor, and then that's going to be, that code is going to be used in a robotics class, or it's going to be incorporated into the Lego Mindstorms or something along those lines. So then one has to think about move from the two-dimensional space to the three-dimensional space, and does that work for every classroom, for example? Could other students in other schools use that technology and program their robots around that in a way to where it would work for them? I mean, if we are looking at a cafeteria size space for the movement of the bot, maybe one needs to revisit that. And those are conversations that students can have, and that gets to issues of socioeconomic status of schools and wealth and privilege and those kinds of things. In the frameworks, they tend to focus on more limitations that are more focused on physical limitations, right? So motor limitations, perhaps someone is injured, their hand is injured, or their hand isn't functioning. How does one work with one hand? And having students think about some of those exceptionalities or some of those physical limitations that other end users may experience. And they talk about, for example, creating a project or that's accessible by people who are deaf or people who are blind. So those are conversations that for the younger kids are more easily accessible to them and they can think about. Interestingly enough, the frameworks don't discuss it. They discuss it, but they don't give specific examples of what is a teacher to do when they're discussing gender issues or gender issues related to ethnicity and wealth and those kinds of things. Those are more difficult conversations to have in the elementary grades, and not that those conversations shouldn't be had, but if students are beginning to think about reflecting on themselves and then reflecting on other students, then that makes that conversation much more easier to discuss in the classroom, and done in a way to where the students aren't actually reinforcing stereotypes that are out there. So that's the concern with this kind of approach to computer science education. But if one takes the approach of making a technology accessible to as many users as possible, then teachers, don't have to have those difficult conversations. So the other piece of that is the students actually considering what do the end users prefer and how they interact with technologies. For example, the gender question is one that's students can easily grasp. Oftentimes what we know is that female students are more interested in social games, and male students tend to be more interested in, kind of the shoot 'em up games or some of the, I want to say, more violent games, which that in itself is a socialized thing for young male students and young female students. But at the same time, having students, for example, female students could create a game that was not a social game, right? So that they're actually having to consider these other types of preferences and needs and wishes and how they're designing their projects. That is not what their own preference is. So that's the goal there. And teachers can be creative in doing that in a way to where some of those more uncomfortable conversations don't occur, so that it is purely a learning experience for students where they're considering new skills and new ways and new points of views. And the last piece I would add to that is understanding that how accessible the project that I'm creating and the design that I'm making as a student, that can be broad. For the example I gave earlier of making sure that the fonts are big enough. Students get that. That the colors are accessible, that it's not just based on I think of my daughter when we had, my wife and I had so much trouble finding clothes for her that didn't have the I'm a princess theme going on. You go to get your daughter clothes, and everything is pink and everything has a unicorn or a princess on it. So those are the signals I'm talking about, and then pushing students to gain new preferences and then understand the preferences of others. And the third piece to this, and we know that the younger grade students are very quick to advocate for themselves and others, but over time, early on, but over time, oftentimes you begin to see some of that waning, and that's something that is socialized with kids. So we know that if the classroom is not inclusive and is not structured in a way to where students feel safe and they feel comfortable in being able to express some of their own needs or needs of others that they see, like perhaps an injustice that they see. It's very easy for us as teachers, because we have so many things going on in the classroom, to even unintentionally shut that kind of communication down because we're trying to get something done. But what I would encourage you to do is to really try to pick up on that. Just spend a day going into the classroom that day, and with this perspective in mind, that you're going to, and how the students interact in the projects, the products that they're designing computationally, and the development methods that they use to create these products, that you're thinking about bias along the way. And if that is the focus and the attention, even if it's an underlying thing, then as a teacher, one begins to see this more and more. But it takes intentionality on the and a different way of teaching to be able to get there, and a lot of work. It's not easy. It's not easy. So especially on this point, oftentimes what I've seen is that students will speak out on what their needs are, or they advocate for others, and it's around what the classroom rules are, which is great. We want that classroom environment to help to be set up in a way to where it's self-managing, but then applying this to the actual work of the subject matter, the learning, and what is, in this case, being learned from the perspective of computer science, that there's a big disconnect there, right? Because we're not thinking about, as teachers and as students, because they haven't been taught to think this way, they're not thinking about beyond the classroom, or even within the classroom, and what they're creating and how they're designing these projects, and how they're coding, how the sprites are interacting, how the backgrounds are changing, what is being broadcasted in a particular project, that actually goes beyond what the student or their group is considering. So this is something that really needs to be taught to kids, and again, elementary teachers are in the best position to begin to do this work, because, I mean, I've been doing this quite a while, but what I've noticed over time is that students are becoming more and more in tune to these pieces and these issues of diversity and injustice that we as teachers probably did not experience in our own education. So, but what I would stress again is that in certain fields, we know that not enough has been done. So beginning to promote this with our students is important. This can take the form of how one introduces a project, and then so that as a discussion around what the project is going to entail and what the choices are going to be available to the students, actually having a brainstorming session with the students on what needs should be addressed in the design of this project. Are we creating something that can be used by many, many, many people? Perhaps students who are older than the students in your classroom. If we live in a rural environment, students that live in an urban environment, if we live in an urban, and vice versa. Or are we continuing to develop and teach computer science or other subjects in a way that is just limited to the experience of our classroom and our students? One of the great things of, I go back again to Scratch, is that you have a whole platform where you have a few million users, end users, and you have millions of projects that can be accessed by students. So as students begin to access these projects, having them evaluate what does this project say about the designer, and who was the person or the user in mind whenever this project was created, and does the project, was it designed in a way, and does the features of the project itself, are those pieces accessible to many students? So this is hard work, and then this moves away from the skills, but and that's highly important too as well. But this is definitely a piece that all people who are integrating computer science in the classroom should be considering in how they're designing their structure in their classroom, the types of projects, how they're assessing, and how they're managing their classroom environment. This needs to be at the forefront, and this is applicable to any subject or any type of teaching that's occurring. So that's all I have for today, and we will pick up in a couple of weeks from now, and we're going to be starting to focus on more of the coding skills needed to get some of these projects running, and then we will begin to consider more in how does the classroom, how do you structure the learning environment in a way to where students are communicating, participating, and interacting in a way that's conducive to learning, that is considerate of some of the higher level skills that we want to see from computational thinking, for example. And are we structuring this in a way to where our students are interacting with diverse communities, so, and participating computationally beyond just the classroom? So that's where we're headed, and I look forward to the next session. Thank you.